Hi guys, John Catalano here from Diamond Audio, and on today's workshop, we're going to be showing you our DSP software, how to get set up and started real quick. So today we're going to be talking about our MS DSP 88 and the software that's included with it. You can download that software and the manual from diamondaudio.com. All right guys, so first thing we're going to do is we're going to open our software. Um, some computers, depending on your virus software situation, you're going to have to run this software as administrator. Also, you do not want to be running this on like a Chromebook or something like that. It needs to be a Windows-based PC, hopefully at least an HD screen. You can resize the screen, but we've run into where there's other size screens that are like 800 by 600, and unfortunately those are not going to be compatible. So just if you run into where the software is cut off and you can't adjust the screen size, that is just a little caveat that you need to know. You need to have a computer that has a little bit of resolution to it. With that being said, the first thing we're going to do is we're going to connect our USB to the DSP itself, um, and then you're going to hit this connect button. So I'm not in a vehicle. I don't have the DSP actually connected, but that's what you would connect. You would establish your connection. It will talk to the DSP. And if the DSP had already been set up in any way, shape, or form, you would get the previous settings would go ahead and show up here on this graph, so you know that you have something there. Um, Otherwise, there you have it. That's pretty much the initial setup. You're going to hit connect. You're going to establish that connection, and then you can start tuning. Okay, first, what we're going to want to do is we're going to want to set our crossovers depending on how our system design is. Again, we have 8 channels of uh, adjustment here. So we can go down here into the crossover section, and we can pick the style of crossover network we like. I don't have enough time to explain what the different crossover types do, but I typically lean on link widths personally. So we'll go ahead and set that there. And then let's say we're gonna adjust channels 1, right? Let's say that this is going to be our tweeter crossover. So we can do high pass, low pass, band pass, whatever we need. So we're going to go ahead and leave this. We're going to cross these over at 5K, so we can type in 5,000 hertz right here. And then we can pick our crossover slope. Let's go with a 12 dB slope. And then we'll hit enter. And now you can see in the graph, we have a 12 dB slope at 5,000. But actually, I did that backwards, so let's start that over. We want 5,000 on the high pass. We want nothing on the low pass. There we go. So basically, we're crossed this over at 5,000 hertz at 12 dB, and this is our roll off. Now, if we want to do this, obviously, most situations, you're going to be doing the exact same thing to the other side. So you can link these together, and we can copy channel 1 from channel 2. So there's a little link button right here, and we can go ahead and copy channel 1 to 2 and hit OK. Now we have the same crossover point, right? So now channels 1 and 2 are identical. Let's go to let's say this is going to be our mid-range, so we're going to band pass that. We want a little bit of overlap, and I'm not going to be very specific with these. These are just generic numbers just for reference, but we're going to say we want to cross over this mid-bass at 100 hertz. That's also 12 dB, and then we're going to cross this over at the 5K like we did our tweeter, so we have a little bit of overlap. And now we have our bandpass crossover. Again, I've only adjusted channel 3, so now I can go ahead and link these. And then we're going to copy channel 3 to channel 4. I'm going to click OK. And now channel 4 has the same settings. Pretty straightforward. Let's say we only have, let's say we're just using coaxial or something in the back for rear fill. So we'll go ahead and we're just going to put basically a base blocker for all intents and purposes on the rears. Let's just say 150 hertz on that. We'll do our same 12 dB. We'll let it naturally roll off all the way up. We'll link 5 and 6 together. Click OK. Now we have 5 and 6 are crossed over the same. And I always like to check. I know it's easy because we click the button, it says OK, but I just look. I go through and I make sure everything looks the way I hope it does. And then finally, we're going to go on channels 7 and 8. Let's say it's a subwoofer amplifier. I know some subwoofer amplifiers only will have one channel of input, but for the majority, it will have two. So we'll go ahead and set these both up for subwoofer. If you were doing maybe a little more intricate system, maybe channel 7 would be center channel, and then channel 8 would be for subwoofer. You could definitely do that. You would just use those independent of each other and then adjust your levels and crossovers accordingly. But let's just say that they're the same. We're just doing a basic system. So this will just be our subwoofer. We're going to go ahead and cross these over at 100 hertz. Again, 12 dB. That's our setting. We're going to go ahead and copy 7 to 8. Click OK. We'll check just to make sure. And now we have the same setting. So now we have all of our crossovers set up. It's pretty straightforward. Again, if you needed to do something tweaky, you could disconnect these. Channel 7, let's say, is your subwoofer. Channel 8, maybe a center channel. Then we could do a band pass. Maybe we're going to do 500 hertz. Or I'm sorry, maybe let this roll all the way off the 20K. And then we'll do 500 on the low pass. And then now we have a nice 20K. Oh, I'm doing this backwards. 500. Okay. And then another thing, so I don't forget, we got to make sure we go back here and click our link width. So let's go and check these. It's an easy one to forget. I forgot it myself. We're going to go back and check our work. All right, everything's set the same. We're done setting our crossovers. Now we can move on to the next step. All right, so now that we've got our crossover set, we should be taking some initial RTA readings from the interior of the vehicle. So you want to set your mic up, ear level, head position on the driver's seat, and you're going to take your initial settings, your initial measurements. And then we're going to look at that graph, and then we're going to see if we have any problems that we need to adjust for. We could have a spike at certain frequencies. We could have some dips at certain frequencies, depending on, you could have a leather interior, a cloth interior, things like that, where you might have certain frequencies are getting bounced around and reflected, and they're louder, and then you have others that are being absorbed by the materials in the vehicle. So this is why you have to test every vehicle. Just because you're putting the same speakers in the same car, they may have different interiors, or the seat position may be different. So there's lots of variables there. So we want to be testing every vehicle after we've done the installation. So just for intents and purposes, let's say we did this installation and the tweeter positions on channels 1 and 2, we're getting a big spike around 7,000 hertz. Maybe it's reflection off the dash. Maybe it's inherent to the tweeter itself. doesn't really matter. We're going to fix that. We're trying to get a flat signal. So if we were looking at our RTA, we'd have our RTA running with our test tone, or I'm sorry, our pink noise, and then we could go in and we can pick 7000K, which there isn't 7000, right? Right here we have 6300, and then next to that we have 8000. So those are the presets. But luckily, this interface is parametric. So we can go in here and I can, let's just pick the 8000 band, and we can move this over to 7000 or wherever the case that might have been the issue. And then we can just bring it down a little bit. Whatever the bump is, if it's a 3 dB, 4 dB, whatever it happens to be, we can just account for that right here. And the graph here is showing you what we're doing to the signal. And then your RTA should be showing you what's happening in real time. So the combination of those two things will allow you to adjust for that anomaly and then see what's happening in real time as you're adjusting it in the interface. So this is a great tool. So we've gone ahead and adjusted that. And let's say we have a dip at 3000 hertz. Again, I know that we have a roll off there, but we do have a roll off. So we want it to roll off evenly. If it's dipping too quickly, we could boost it there. So again, on the interface, we have 2500 hertz and 3150, right? So we're going to pick the closest one here, and then we're going to bring that over to 3000 or whatever that frequency may have been, and then we can go ahead and give that a little bit of a boost to account for that dip. So now our high frequencies are even for the most part. Now this could be the roll off between the mid and the tweeter. That could be affecting it as well. So we're going to do this to the tweeter first, and then we're going to go back to that mid range and see if there's anything that we need to do on that mid range. You may have to go back and forth a couple times depending on where those frequencies are overlapping, and you may have to adjust the mid a little bit. You may have to adjust the tweeter a little bit to get that exactly where you want it. But again, we're looking for a flat frequency response to start with. We're not taking into account anything that could be happening in the vehicle right now. So if we were working on an OEM, let's say an OEM radio, and it's adding things to the signal or cuts or boosts or whatever, we would adjust for that ahead of time. So we could have started out with just the flat signal or just doing the pink noise off the OEM radio and adjusting for that too. But this, for all intents and purposes, this gets us to the same point. We're looking at what we have now, depending with or without an OEM system, and we're going to go ahead and adjust this so we have a flat signal to start with. So let's move along. So we're going to go ahead and do the same thing to our channels 1 and 2. They're already linked together, so they're going to adjust together. Now, you could have a situation where you need to adjust them separately, and that's fine. You can just unclick that little link button, and then you can adjust the other side separately. Maybe the application that you're working on doesn't have a symmetrical installation possibility. Maybe the tweeter has to be in a different location, or the mid-range is in a different spot, or there's other things that may be in the way. If you have an asymmetrical setup, you can go ahead and uncheck that and go ahead and adjust accordingly. But right now we're going to keep them linked, so I'm going to put them back. And now we're going to go to the mid-range. Let's say we have a dip, again, just for argument's sake, at 400. We can pick our 400 hertz frequency here, and then we can just adjust. Control Z, or I'll just go back. We can pick 400, and we can do this one of many ways. See, I can pick it on the EQ itself. I can grab the level here. It's very easy. You can do it however you want. You can move these left and right. You can type them in. Let's say we wanted this at 500 hertz. I can type in 500 hertz. Anything you want to adjust, the Q, we can adjust the gain of that. So if we're boosting it, we can adjust it here, like plus 3 dB. So we can just type in the number, or we can do it with the level again, or we can do it with the graphic interface here. So very, very easy to adjust. Whatever you feel more comfortable with. If you know what that tune needs to be and you want to type them in manually, knock yourself out. Obviously, that's even more accurate. But if you want to just do it manually by hand, please feel free to do it that way as well. We tried to give you lots of options to adjust this interface. So again, let's say we have our 400 hertz here. I can see on the RTA that it's right at 3 dB down, so we're going to just boost that 3 dB, and now we're done. We've added our 3 dB boost at 400 hertz. Let's say, since we're talking about this graphic part of the interface here, this Q value is basically how wide this frequency is rolling off left or right of the center frequency. So we've adjusted this based on 400 hertz. So we know our center point is at 400. So now we know that 1.41 is, it's basically adjusting 1.1 or 41 to the left and 1.41 to the right of that center frequency. So we can adjust that here. We can make that 3, which is going to be a wider adjustment, or we can go narrower if it's a very, very weird anomaly that it's super tight and we just want to go really dial into that one frequency. We can do that by making this number smaller, let's say 0.5, and it's going to make that gap even narrower, right? It's just a blip. Just for illustration purposes, I'm going to make this a really big gap, just so you can kind of see how it spreads out. Let's make it 10. I'm sorry, the other way around, minus 10, or I'm sorry, 0.1, 0.1. And now it's really wide. It's spread out, right? We wouldn't do that typically, but I just wanted to kind of show you what it does to the interface. But we can smooth out that adjustment by adjusting the Q. So now that we've done that, we have the same adjustment on 4. We can go to our subwoofer. Again, you might have a bunch of cabin gain where you had a big boost at like 50 hertz or something, or 60 hertz. We can go ahead and find that center frequency, and then we can just put a little bit of a dip in there. Maybe we need a little bit more at 100. We can boost that here, and now we've adjusted our subwoofer. I'm sorry, that was the rear fill, but you get the point. And then same thing for the center channel or the subwoofer. We can adjust all of those things through this interface with the sliders, with the graphic interface. We can move it center frequencies wherever we need to adjust for, and then we get a visual representation of what's happening. And again, hopefully you have your RTA running and you're seeing it happen in real time on your RTA as well. All right, now that we've got those EQ settings set, our crossovers are set, everything's doing what it's supposed to do, we can jump into time alignment. This one's going to go pretty quick. It's pretty straightforward. Like I had said earlier, I really highly recommend using a metric tape measure, but for ease of speaking, we're just going to talk in inches. And these numbers, again, are not accurate. I'm just making these up as I go just to kind of give you an idea how you would set this up. So I'm going to go ahead and pick our unit of measurement first because it defaults to milliseconds. So we could go to centimeters or inches. I'm going to go ahead and select inches now. And we're going to set this up. So we're going to measure from, first thing we're going to do is we're going to measure from the farthest distance speaker and then the shortest distance speaker. What we want to do here is we want to find our initial differential. And then we're going to base that on, once we have that, we can base all of our other measurements with that. So let's say the subwoofers are 40 inches away from, or I'm sorry, 60 inches away from the driver, and the front tweeter on the left-hand side is 20 inches, right? So we've got a 40-inch differential there. So that's going to be our baseline, right? So we need to do, if we want that subwoofer to sound like it's in the front of the car, we're going to add 40 to this front tweeter of delay, and we're also going to add 40 to our right tweeter, right? So everything starts at 40. So we're going to add 40 inches to all of these drivers. Okay? We're not adding delay to the rears, and I'll explain that when I get to them. So now we have 40 inches of delay on everything. So now the subwoofer is playing, all intents and purposes, in cohesion with the front speakers. But now we're going to adjust for the differences in the front speakers to the head of the driver. So we're going to have that microphone, or you're going to measure to the driver's ear for these measurements. So let's say our front tweeter is at 20 inches. So we already have that measurement. And we go to channel 2 and we see that that tweeter is 30 inches away. So that differential is 10 inches between those two. So we need to add 10 inches of delay to the front tweeter. So it is, or I'm sorry, to the passenger side tweeter. So it reaches the driver at the same time. So we already have 40 because we've centered it from the subwoofer. So we're just going to add that difference to the 40. So now we're at 50. Okay. Hopefully that makes sense. So now we're going to go to the rear, or I'm sorry, the front mid-range on the driver's side. Let's say that it's 26 inches away instead of the 20. So now we had a difference there of 6 inches from the tweeter. So we're going to add that. So we got 20 minus 6. We need to add 6 inches here. So now we're at 46. On channel 4, we've got 30 inches. So we're going to add that differential between those two to the driver's ear is, I forgot my number now. So we're at 30, and we already have 40 added. The differential, that was 26. So we need to add 13 to this. So now we're at 53. Right? So now everything's reaching the driver at the same time. Here's where you have to make a decision. If you're doing rear fill, do you want it to act as rear fill, or do you want it, are you designing the system just to be loud? If you just want it to be loud, you would add delay to the rears. That way all the sound from all the speakers reach the driver at the same time. If you want to give the illusion of rear fill, I would leave that, because that delay will be added in to the overall sound of the what you're looking for, right? So that will be more of a front sound stage with rear fill. The only thing I would say here is I would add the same 40 to this as you did to the fronts, so you don't have an extra delay, right? So we're going to add 40 inches here, just so the delay is equal from everything. So we have a baseline. All right. And then if you have the center channel, we have a differential there. You would measure that and add that in here. And then we already did the subwoofer. It was the farthest driver away, so we have nothing to adjust there. So now we've done our time delay. Pretty straightforward. Hopefully I didn't speak too fast, but there you have it. All right, now we've got our EQ set, our time delay set, our crossover set. It's time to move on to sound adjustment. Sound adjustment is going to be, you're going to adjust this so it sounds good. Now we have a flat signal, everything's aligned. We want to now tweak it so it sounds good to the ear, right? A flat system doesn't really sound good. So you may want to boost a little bit in your upper mid range. You want to add maybe a little bit more bass, and you can do that in a couple ways. You can do it like this is the EQ, and you can go in and you can adjust these frequencies, and you can add a little bit, cut a little bit, depending on what you're looking for. Or if you like it flat, or you don't want to do that much adjustment, maybe the customer has a head unit that has bass treble or some other adjustments at the front, and you just want to give them something flat to start with, you can leave those alone and not adjust it at all. And then what you can do is, then the next step would be, you could adjust levels. So let's say you've already set your gains based on the output of the head unit, the line level signal, and you've adjusted your gains that way. Then what you can do is, instead of having to go and tweak those gains, you can go into the interface here and you can adjust those levels here. So let's say you've got the same amount of power going to the front stage as you do to the rear fill, but the rear fill is just too hot. Like, it's too much output there. There are bigger drivers. Maybe they're 6x9s and you got 6.5s in the front. Whatever the case may be, we can go in, we can link those two channels together, and then we can bring the level down here. So instead of having to adjust the gains of the amp, we can adjust the gain on our signal here. So whatever we adjust it to, negative 3.8, let's say, we can copy that, paste that in here, negative 3.08, enter, and now we're at the same level. Or you can just copy and hit it OK there. So they're at the same. You could also mute channels if you're like troubleshooting. You can adjust phase, like say if it's the subwoofer and something doesn't sound right, you can go 180 degrees just with a simple click and see if you have a phase issue there. So pretty intuitive interface. We can do that for all of them. Same. If we were using channel 7 for the center channel like we talked about, we could adjust that here. Maybe that's also too hot. It's right in your face. We can adjust that level here. And then we can make everything sound the way we want it to sound, not just the way it happens to sound because of speaker placement, volume or level control, things like that. Now we can go in and we can fine tune it so we can get the best possible sound. And then finally, once you have all of that, you can save those settings here. So you go to preset settings and then you can load from a setting or you can save a setting. So let's say that's our setting. We can save it. And then that's going to send it to the DSP so we know it's locked in. We can also load settings from a USB drive or that we've saved on our computer. Let's say we've done the same vehicle, or some odd reason the customer got in there and downloaded the software and messed everything up, and you've saved the settings. You can go ahead and reload them in, hit save. It'll load those settings back into the DSP and you're good to go. Or you got a competition vehicle and the guy likes the way it sounds a certain way, but he also wants it to sound a different way for competition. I understand. Same thing there. You plug in the DSP, load your settings, and you're on your way. Well, I appreciate you listening to that. I know it's a lot to take in, but hopefully you've taken away the fact that DSP shouldn't be scary. It's really easy to use. Once you've done it once or twice, you'll be a pro. Break out that RTA, use that RTA with the DSP. You're going to be happy that you did. Your systems are going to sound better. Your customers are going to be happier. You're going to have less issues running down the road. You're not going to have people blowing up speakers and things like that because everything's set up the way it should be. I just want to close it out with one final tip. With great power comes great responsibility. Be easy with those EQ settings. If you're fixing an anomaly, that's a different thing. But we give you a lot of adjustment there. There's 18 dB of adjustment. If you're adjusting more than maybe 6 or 7 dB on something, you may have an issue somewhere else that you need to be looking at. So just be careful with that. You have the tools to do what you want, but that's just something to keep in the back of your mind. Less is more when you're doing adjustments. So with that, I'll leave you, and I appreciate your time.